Well, hello and welcome to another one of our Energy Code webinars. My name is Mike Barcik and I'm accompanied by my friend
Ali.
And this has got a long title. We must like long titles. So this one says, highlighting the differences between the IECC 2015, and I'll put with Georgia amendments because there were a few amendments to the commercial code, compared against the unamended ASHRAE 90.1-2013. So a couple things. Always want to try to emphasize where you can find more information on energy codes and commercial buildings at our website, southface.org. Ali, before we go there, I thought people might want to be interested in seeing a picture of what we look like, and I found that one. And whenever you step out of line, this is what happens. So anyway, with that, now you can see what we look like. The place we want to, can you help me, I'm sorry, Ali, help me get people to, from southface.org, how do we find what we're looking for?
Yeah, so Mike, go ahead and take us to, if you don't mind, our homepage.
Let me get out of here. There we go. There's our picture too. Our southface.org homepage, which is, get over here, I'll pick that one, and I'll go to the logo, which gets us to the home page. Okay.
So from here, you guys see all of the different tabs up top for About Us, Programs, Education. So hover over where it says Education.
I can't see anything that says Education. Oh, there it is.
There we go.
So across the top,
yep.
And Education.
Then hover over Education and click on Our Courses.
Uh-huh.
And then from there, you'll see a couple collapsible menus. Go ahead and expand the one that says Energy Code.
Gotcha.
The last link will say Georgia Energy Code and support documents.
Gotcha.
So that's where all of our resources relating to the Energy Code updates will live.
This sounds starting to get familiar here.
Yeah.
So when you come here, you can read about the outreach grant. There's a lot of resources for residential, some videos for residential. And some tools and things. One of the things I think you'll find really useful is this commercial field guide. And I just realized it actually says Comerical field guide, which we should probably update that. That's good. You look at something for a while, and maybe that's that's the Spanish version, the Campo de Comerico. But anyway, I think it's supposed to say commercial. When you click on that, you will be able to get a document that looks something like this. And this is, I think, a really useful tool because it breaks down the energy code. It's really written around ASHRAE 90.1, but it does compare to IECC 2015. So you can see that in there as you go. But it's based on components. So particularly for the envelope, you can go through by component and see if there's something that's different in the international code. For example, if I take, above grade steel framed walls, it's down here on page 11, so I'm going to jump down to that real quick. And we're going to cover all this in a little more formal basis. I can't, I just realized I'm in the one that from the website. I think it's easier if I look at it from the one that's on I've already downloaded here. So let's try that again. Let me jump over to a slightly different version. You can see page numbers. And it says page 11. Went too far there. So page 12. So this is above grade walls steel framed. And an example of a difference between the codes is in climate zone 3, it's telling me that I need an R13 plus an R5 for a non-residential building. Then what you'll find is when you look at the, and it's in here, when you look at the IECC, you're going to look at its table, and you're going to see that you actually need 7.5. I'll try it. That was a lot of excitement, wasn't it, just to show that? But in other words, we're going to be jumping between two different codes. The 90.1 code is, and its envelope requirements. Oops, let me get in here. Are spelled out like with these tables. There it is one for climate zone 2, and let's make it for climate zone 3. So we're going to see all this in a second, but it says, you know, steel framed R13 plus R5, and that's for a regular non-residential commercial building. For residential occupant commercial buildings, it's R13 and a steel frame cavity plus R7.5. That's an example of a difference between the type of occupancy. But if I jump from that over to the 2015 IECC, to go find my table here, they, to their credit, tried to fit it all on one page. There's an R value table and a U factor table. Could try to make that work. Now I got to be able to see it. So I'll rotate it. And you could say a metal frame, let's make sure we get our climate zone 3, a metal frame building, all other is 7.5 in this. So it's 5 in the one code, it's 7.5 continuous insulation. That's just an example of where the code's not identical. They're very similar in scope, but they don't line up completely. They came out at different times and they tend to leapfrog each other. So in that particular one, the IECC is more stringent on that particular component. Well, that was exciting. Let's try that in a little more formal definition. I'm going to kind of launch in here and go to slide number 24. So from a content standpoint, they're very similar in their content. They're covering envelope, they're covering mechanical, they're covering lighting. Those are sort of the big things. And both of the codes have a simulation option. If you can't make it work with the prescriptive code, you can try to do a whole energy model. This is the one I've seen people do a lot, which is called the energy cost budget method under 90.1. Virtually every lead project usually has an energy model, and they're almost always following that. So that's an important detail. Here's another good thing, how to look at the code is you've got certain things are always mandatory, they have to be done, and then you can either meet, for example, on the envelope, the prescriptive code, you can meet either prescriptive code, or you can do a simple trade-off using ComCheck. ComCheck you will get from the, let's see if I can find it up here. No, that's the one I want. I don't want to stop that one. You go to energycodes.gov and you can either download it and use it on your desktop, or you can use a web-based version. And the web-based version, I think I had it open here, looks something like that. So you describe your project, you give it the basic information here, and then you can start describing it. It's got a roof, it's got walls, et cetera, et cetera. Anyway, I'm not going to do that now, but ComCheck is definitely useful for envelope. But when you're in the ComCheck program, it's going to ask you somewhere, it's going to ask me which version of the code I want. And at the moment, I am not seeing it. Right there, it says I'm in 90.1. Maybe I'm scrolled down. Yep. So anyway, we're going to select the code version. You can either pick 2015 or you can pick 90.1. So you have to pick the right version of the code. And the different tables and the different R values and U factors will plug in accordingly. Okay, let's close that. One of the differences is there's a slightly different definition of conditioned or unconditioned space. ASHRAE sort of says you put a little bit of heating or cooling in it, or you're connected thermally to a conditioned space, then you're conditioned and you got to meet code. Or they do have this exception for what they call a semi-heated, I call it freeze protected, just a teeny tiny amount of heat. You can still usually have less insulation with that approach. And ASHRAE has sort of 3 columns: non-residential, most commercial buildings, residential, ones people sleep in, and semi-heated, freeze protected. The IECC does a little differently. They have a slightly different definition of conditioned space. They exempt what they call low energy buildings that use very little energy, and or ones that don't have any conditioned space, like a shed, but they only have two different kinds of buildings. All other is almost every commercial building, and Group R is the one that have people sleeping in. And then I think that's where I want to jump on that one. So let's try. Boom. So here we're going to jump and talk about insulation, mainly for the opaque elements, things you can't see through. And we'll go to this chart and see this is the chart for climate zone 3 for ASHRAE 90.1, and you'll see it requires, and you'll see a different answer if you jump a climate zone. So for climate zone 3, it's R25, continuous insulation above the roof deck. If you go to climate zone 4, it goes to R30. So that's an example of a change in climate zone, but still within the same code. So everything in yellow is actually what changed between the older version of the code and the new code. Let me think what else. So this is an example. A metal building is under ASHRAE, it's R10 plus an R19 filled cavity. And these numbers are also slightly different, and we mentioned that one right there. So so a couple other differences. When you jump to the IECC for the same climate zone, you'll see very similar answers, but not necessarily identical assemblies. And remember, and the same R value there. I think the mass buildings are the same. Metal frame building is more insulation in the foam board in essence here. Wood frame a little bit more as well. No requirements for basement. So again, you just have to kind of compare the two for a given climate zone. Georgia did make an amendment that said we're not going to require slab insulation anywhere for climate zone 4 unless you put radiant tubing in it. That would make it a heated slab, whereas ASHRAE for climate zone 4 would require it. So that's a small difference, but that's probably the big stuff there. When you get to windows, there's a table and requirements for glazing. ASHRAE basically, maybe I should go back to that, sorry. Well, anyway, ASHRAE has this as its requirements. It's a 0.35 U factor the U factor depends on the frame type. Typically, it's like a metal fixed metal frame, it's 0.5. That's pretty easy to hit. But this is kind of the tail wagging the dog, the low solar heat gain coefficient. Also, ASHRAE has something that the other code doesn't, which is this ratio of the visible transmittance of the glass divided by the solar heat gain needs to be at least 10%. That's basically saying it's favoring visible, or it's favoring low E coatings over a tint, because a tint would block the solar gain, but it would also tend to block a lot of the visible light. So you might not hit that with some tints. Darker tints would have trouble. And in terms of overhangs, ASHRAE has much more credit for overhangs, projection factor, which is distance of the overhang divided by distance to the bottom of the glass. And whereas the other code, it pretty much just said, here's your U factor. It's simpler, I will grant you, but it doesn't give you as much design flexibility. Here's your U factor you have to beat, and here's your solar heat gain depending on your orientation. And you either have small overhangs, small projection factor, that's basically no credit. Medium, you get a little bit of credit, and large, you get a little bit of more credit. But your glass solar heat gain would have to meet these requirements, and that depends on the orientation, south, east, or west, or north. And ASHRAE has the similar thing for all orientations except for north. So same kind of setup there. Once again, I always remind people, you are in much better shape to use ComCheck and do your envelope components with ComCheck. So you put in an exterior wall, and let's say it's a steel frame 16-inch on center wall. I think my ComCheck went to sleep. It's time to wake it back up again. Let's try again. Yeah, we have to pick the right version of the code. We have to pick the right state, and our city, ATL, Athens, Atlanta, and then down here we have to tell it what type of building it is. I like to make it a retail building, and we'll just pretend it's 8,000 square feet. So now under envelope, I can click on these tabs and I can describe, well, we've got a roof. It's a insulation entirely above the roof deck, and we're going to put a shiny roof on it. So I'll put a 0.6 and a 0.8. Higher is better on these. I'll create this roof. So it's a high albedo roof. Give it the area. And if there's more than one roof, you can make two entries. But anyway, I'm describing the envelope, and I'll put in R25, that's prescriptive, and so on. But if I come to a wall over here, this is what I was trying to show with windows, I'm going to make it a steel frame wall, 16-inch on center. You actually have to place the orientation of the wall because it needs to know the orientation of the windows now. So let's say there's 2,000 square feet of wall, and it's R13 in the cavity, and we'll make it an R6, continuous. And notice, now, once I've made a wall, I can subtract glass out of that. So I'll put a window, and we'll just take a metal frame fixed. I'll use data that is in compliance with the NFRC. So I'm going to put a 0.4, 0.28, no, let's make it worse, 0.30 solar heat gain, and 0.5 visible transmittance. And I'll call this AAA. Now I just need to say OK. And I have created a window. It's going to let me subtract the area out of the 2,000 square feet of wall. So these windows will face east. So let's just say I have 400 square feet of glass. So that knows, it'll do the math. It'll subtract the 400 out of the 2,000, since this window is shown to be a subset of that exterior wall. CommCheck is your friend, does all this for you. The other thing is, if you have a projection factor, let's say we have a 6-foot overhang and the bottom of the window goes to 9 feet, well, I can take credit for that. So that's 6 over 9 is 2/3 or 0.67. That's my projection factor. And that will give me credit when I later run compliance. I have to describe the entire envelope, which I clearly haven't done, but it does have to actually do a complete simulation. And we'll see, it's either going to say it passed or it failed. It doesn't mean anything really at the moment because I haven't entered all 4 walls and haven't entered the slab and stuff like that. I've just entered 1 wall and the roof. But when this thing crunches it out, this is in essence what we're trying to accomplish, is to achieve you'll see a green passing bar, which we did get. If it doesn't pass, it'll say red. And once you pass, and all the envelope, of course, has been fully described, then you can do a report. You can generate a report, and this is what you turn in for compliance. So you can do the same thing. The code I used was 90.1, but you could also use 2015. Now it might have some slightly different U factors and different requirements. That's okay. So we could, switch that and try running it again, but you get the idea. Okay. So back to where we were. Trying to make sure I see if there's anything else big change-wise. The overhangs. So that was slide 75. I want to jump to 81 and remind everybody, I think I mentioned this one, about only in ASHRAE do you have to show that your visible transmittance is greater than your solar heat gain. Again, that's prescriptive, so you could trade it. All right, that's 87 is vestibules. So vestibules for ASHRAE has this one very important exception, that when you do not have to have a vestibule, and it's this one. It's about entrances. Ooh, I'm drawing that right here. So if you have an entrance in a building that's under 10,000 square feet and 3 stories, you can exempt the vestibule under ASHRAE. That exemption does not exist in the other code. Let me discard that and try to show you that. So you kind of have to sort of compare the 2 codes side by side. And oops, I got to rotate that back. And we can go through and see if we can find the section on air sealing. So somewhere on section 402.5 starts talking about air leakage in commercial buildings. And when you get down into it, it gets into vestibules being required. And I can't seem to put my hands on it. And vestibules. So vestibules are required, and in any, except in climate zones 1 and 2, that's the same. These are all the same as ASHRAE, but that 10,000 square foot 3-story or under building is not in here. They do actually have an exception for an air curtain, whereas ASHRAE does not. So again, a subtle difference between the 2 codes on how they approach vestibules. So that's another example of a difference. Let me go back to my presentation. Let's go to 89. Can lights, that's another thing. They're a little more clear in the IECC. They spell out that if the can light is airtight and IC rated, they're not going to sort of penalize you. If it's not under ASHRAE, you're going to have to do some math. So you always want to make sure it's the correct kind of can light. And then lastly, I wanted to mention, this is kind of an interesting one. The IECC actually credits you for approving air sealing. One way of doing it, it's an optional way, is to do a blower door test at 75 pascals. And here you're usually going to use multiple blower door fans. This is a building that we were testing in Virginia, and we used, I think, half a dozen blower doors. You can see 1, 2, 3, 4, 5. I think another one's on another door. And you add up all the air through each fan, and that totals out to be the building CFM at 75. And if that number divided by the skin area, the square footage of all the walls, the top floor ceiling, and the foundation of the slab, if that ratio is less than 0.4, you pass code. And so that's a way of proving air sealing. That unfortunately is not in ASHRAE yet, but that's a great idea. We call it envelope leakage ratio, but it's the same thing. It's the CFM at 75 divided by the shell of the building. And if that number comes in below 0.4, then you pass code. So that's a good example of that. And is there anything else big on that? I think those are the big differences between envelope. When you go to lighting, I've got some summary slides here. The major things that might be different or might be the same, I guess, with note, ASHRAE does not regulate dwelling unit light fixtures, but this one does. So 75% of all light bulbs have to be efficient. And Ali, I know you're there. When I say efficient lighting, what technology do we want?
LED.
You got it, brother, LED. So in terms of controls, I like to say that they're asking you to do very much similar things, but they word it very, very differently. They approach it very differently. So, they specifically say we want occupancy sensor or vacancy sensor controls required in these 12 spaces. So, these are, again, a similar list of requirements in ASHRAE, but kind of a different way of wording it. So anything like a lecture room, a classroom, a conference room, copy room, print room, break rooms, private offices. Some of these, especially with windows, really make sense for vacancy sensors. And vacancy sensors are manually turn the light on, but after that they operate like an occupancy sensor, and that once people leave, they'll automatically shut it off. So vacancy sensors are usually better in places that do have windows, whereas occupancy sensors might be better in a restroom or warehouse. Well, it depends on whether there's windows. So anyway, that's just a different approach to how they're doing it, and but again, asking for automatic controls. They have similar requirements about shutting the lights off when nobody's in the building, so time clock operation. There's, again, always going to be exceptions of places where it's not required or it just doesn't make sense. And they also want you to be able to reduce light levels in a given space to about 50%, so that you can give more than one option for all on or all off. You know, you got one at least in between. They give you, they would like you generally to have the control be located in the space. And if it's not in the space, both codes give you an exception, like if it's a big box retail store, you don't want the light switches in the lobby. So you're going to put those in the, you know, in the back of the building, but they have to have some sort of status indicator that the lights are on in the main part of the retail store. They have, you know, this IECC has identical description, or I guess I should say definitions of what makes a zone daylit, and they want daylight responsive controls if you have more than 150 watts. So again, this is lining up very much with ASHRAE. And they have certain areas where they say, we're not going to count it against your budget, but we want this lighting to have its own control, similar to ASHRAE, display lighting. They do have switched receptacles required in hotel and motel. ASHRAE has that as well as in addition to a few other spaces. Like, so that's something to look in. That's a difference in ASHRAE. Any of these, they're not counting against your budget, but they need to have their own switch. So, you know, if you're selling light fixtures, that's great. We're not going to count against you. That's what you're selling, but they have to be on their own control. Outdoor lighting, again, very similar to ASHRAE, automatically off when there's daylight out. It has to have a curfew lighting capability, which is roughly at midnight. The light levels need to, outdoor light levels or power needs to drop 30%. And, oops, I'm sorry. And then, again, you can do lighting of your facade, but with constraints. And they still include exit signs. I think basically everybody uses LED exit signs, so ASHRAE, I think, took it out. You can exceed your budget. The budget is created in the quick and dirty or the space-by-space approach, so it's very, very similar. And they do give you additional lighting power if you go space by space, but they don't have quite as many sort of bonus wattage opportunities as 90.1. So no room cavity ratio for tall geometries, and no extra wattage because you have much more complicated or sophisticated controls. They are very similar in outdoor lighting. Again, they always have certain light fixtures that don't count against your budget, just like ASHRAE, but generally they have to have their own light switch. And that's basically it for that aspect of it. When you get to HVAC, probably the big thing is, is what do they have in common? They both want you to do load calcs. They both have minimum equipment efficiency. Georgia said, scratch the ones out of the IECC and make everybody use the equipment efficiency tables from 90.1. It's a good idea. Simplifies things. All ducts have to be sealed, insulated, and balanced. Test and balance is huge. Everybody has to do it, no exceptions. And there is a calculation that sort of shows that you don't have too big of a fan trying to move too much air through a too restricted duct. So there's a fan motor power calculation. It's very similar to both codes, if not identical. And then they're very big about equipment being shut off when nobody's there, and some degree of sort of proving it. ASHRAE has something the other code doesn't. It has this simplified approach, which has 18 items. If you can check the box and you're a fairly simple commercial building, 1 or 2 stories, under 25,000 square feet, you can tick the box on these, you're basically going to automatically be done with complying on the mechanical side. So it's very simple. It's not in the other code, so that's something to be aware of. If you're using the IECC, you must essentially comply with all these mandatory requirements. And the list is long, and it's like, if it's in your building, do it. If it's not in your building, ignore it. So if you don't have, Ali, do you have a snow or ice melt system in front of your building?
Never had one in Miami.
Don't have,
and I don't
not
have
in Miami, really? They make a lot of sense there. Or freeze protection, yeah, okay, so those you don't, you can just skip it if it's not in your building. But if it is, or if you need to comply, read the section about it. Like economizers are back in the code. Demand control ventilation is a big one. So, again, follow the rules. And I think it's worth mentioning that some differences, some things that Georgia amended in the IECC, but not in ASHRAE. In some cases, making it similar. Equipment efficiencies amended to be identical to ASHRAE. Kitchen exhaust hood requirements only in the IECC caused some people heartburn. Those were deleted. Ducts have to be sealed, and ducts have to be insulated. The I code does not have an exception for computer rooms. Georgia said that's silly. We added that to make it line up with ASHRAE. A little bit of language needed to be cleaned up about pump isolation in this. It was just written poorly. But and a 5% limit, that actually makes the simulation option identical to ASHRAE. You can get credit for renewable energy if you do a computer model, but you can't get more than 5% credit. And then again, some commissioning and things like that. So in essence, the only other thing that's different between the two codes on a higher level is that when you're all done with the IECC, you're not all done. You have to actually do one of these 6 bonus things. You have to do something extra, and that's not in ASHRAE. So one of the extras is more efficient HVAC equipment than you minimum. Another extra option is a dedicated outdoor air system. These are a really good idea. Another probably easy one is just to put in more efficient LED lighting, beat the lighting power densities by a certain amount, or more sophisticated lighting controls. That can be one of your 6 items. Or put in some renewable energy and get credit for it. Or if you use a lot of hot water, put in a more efficient water heating system. So Ollie, I think that takes us to the finish line. We are have quickly summarized some of the big changes between the two codes and what you might need to be aware of. And again, I guess I want to emphasize, once you pick one of these codes, you have to do everything in it. So if you do lighting under IECC, you have to do envelope and mechanical as well. And you got to stick with all ASHRAE 90.1 or all IECC 2015. And I think that's it.
Sweet. Well, thank you, everyone.
All right, thank you.